Hello, everyone. This is Professor Robert Solis. How are you doing? We're going to work on this particular expression and see if we can solve it or minimize it, I should say, using KMaps. We're going to see if we can reduce it using also Boolean algebra. And then finally, we will draw the circuit using AND gates, OR gates, etc., etc. All right, so I've already drawn this KMap graph, and just it's the same thing as the previous videos. You start off over here with splitting this up. Since I have four variables, A, B, C, and D, I'll do A and B over here. C starts at the top, and then D. But we don't want to count in binary, so this is going to be 0, 1, 2, 3. Well, I just counted in binary, but I didn't count in binary in order. I didn't go 0, 1, 2, 3. The way it works out is 0 and the 1 go over here, and then the 2 and then the 3 go over here. Likewise, for columns, it's 0 and the 1 go over here, and then the 2 and the 3 go over here. All right, well, now that I've got this, let's take a look at what we've got over here, and let's see if we can go ahead and create the various terms that I've got over here. So you'll notice over here that for D, it looks like it's D naught, so that's going to be 0 for this guy over here, which is just simply D naught by itself. So what do I do with the A, B, and C? Well, with the A, B, and C, it doesn't matter, right? So I'm just going to put X, X, and X over here because really this is just about the expression D by itself. And in this case, it has to be D naught. So I put for A, B, and C, it doesn't matter if it's 0 or 1, and I'll just represent that with an X. Over here, for C and D, so for A, I'll put an X, for B, I'll put an X, for C, that's got to be 1, and then for D, that's got to be 0. All right, and then over here for X, for A, I should say, I'm going to put an X because it doesn't matter what that happens to be, but definitely B has to be 1, C has to be 1, and D has to be 0 because you see the D naught right there. And then finally for this, well, the only way that this can be true is if A, B, C are true, and then D is 0 for false. That takes care of this. All right, now let's go ahead and place the ones over here that represent all of these different possibilities. So I'll start off with the easy one, 1, 1, 1, 0. Okay, so 1, 1, that's this row, and then 1, 0, that's this column. So I'll put a 1 over here for 1, 1, 1, 0. Okay, that takes care of that. How about this guy over here? Well, again, this X could be a 0 or a 1. So let's start off with a 0. So 0, 1, 1, 0. So 0, 1, and then 1, 0. So that's going to be this guy over here. Now let's let this be a 1. So that would be 1, 1, 1, 0. So 1, 1, 1, 0. That's already marked, so I don't have to worry about that. All right, for this guy over here, we have 4 different possibilities. So this could be 0, 0, 0, 1, 1, 0, 1, 1. So let's start off with the 0, 0. So 0, 0, 1, 0. All right, 0, 0, 1, 0. That's this square right here. That could be 1, right? 0, 1, 1, 0. So 0, 1, 1, 0. That's already marked. Leave it alone. 1, 0, 1, 0. Okay, so 1, 0, and then 1, 0. That's this guy right here. That's not been marked, so we'll take care of that. And then finally 1, 1, 1, 0. So 1, 1, 1, 0. That's already marked. I can leave that alone. All right, now here I've got to consider 8 different possibilities. This could be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, and then finally 1, 1, 1, with of course a 0 at the very end. So let's just take it step by step. I'm just going to count in binary in my mind. So we'll start off with 0, 0, 0, 0. Okay, so 0, 0, 0, 0, that's this square right here. All right, and then 0, 0, 1, 0. So 0, 0, 1, 0, that's already taken care of. So I said 0, 0, 1, 0, right? You know what, I better put this down because I'm going to forget. So we already took care of 0, 0, 0, 0. And so now the next one would be 0, 0, 1, 0. We just took care of that, right? 0, 0, 1, 0. So now let's do this. We'll say 0, 1, 0, 0. So that I'm counting from 1 to 2. So 0, 1, 0, 0, 0, 1, 0, 0. Oh, that's this guy right here. Okay. Next, we'll increase by 1. So 0, 1, 1, 0. Remember, this column always is going to stay unchanged. Boy, that's a terrible straight line here. I'm still learning how to use my tablet. These numbers are always going to be 0 because that do not, right? It's the A, B, C that are going to change. All right, I'm not sure if I took care of this one. 0, 1, 1, 0. Okay, so 0, 1, 1, 0. Doesn't matter. It's already marked. Leave that alone. All right, so increment that by 1. So this is going to go to this 1, 0, 0, 0. So 1, 0, 0, 0. That's this guy right here. Has not been marked. And then I increment that by 1. So that's going to go over here to 1, 0, 1, 0. 1, 0, 1, 0 is already marked. Then I go to 1, 1, 0, 0. So 1, 1, 0, 0. That's this guy right here. Nice. And then 1, 1, 1, 0. So 1, 1, 1, 0. That's already marked, so we can leave that as is. And that's it. All right, so we've taken all these terms and all the different possibilities, and that's how you handle, by the way, if you don't have an A, B, and C in here, then you just put X's over here, which means that it can be either zeros or ones. Over here I have a C and a D, but I don't have an A and a B. That's why I put 2 X's over here. That's how you handle these terms that don't necessarily have all of the other letters that you've seen. And in this case, this kind of reveals to us, hey, we needed an A, B, and a C and a D for all of these, and we're going to express the ones that are missing with X's. Then we're going to fill these in. All right, right off the bat, I see 8. Check this out. So I want to circle these guys right here, and those are going to be grouped with these guys right here. Look at that. That's a group of 8 right there. Wow, that's beautiful because I started off maximally thinking about as big of a grouping as I can, and it has to be 2 to the n power, right? So 1, 2, 4, 8, 16. I can't circle 6 characters. I can't, or terms. I can't circle 14. It has to be the 1, 2, 4, 8, 16, 32, so forth and so on. Okay, so now that I've got this, let me go ahead and see what all of the different possible terms are. So let's start off with this one, and then this one, then this one, this one, this one, this one, this one, this one. So we'll start off over here. And so it looks like it's 0, 0, 0, 0. Okay, so let's go ahead and put 0, 0, 0, 0. Then I have 0, 1, 0, 0. Okay, so 0, 1, 0, 0. Making sure to be careful to do A, B, C, D. So this is A, B, C, D, right? 1, 1, 0, 0. 1, 1, 0, 0. Okay, next one, 1, 0, 0, 0. So 1, 0, 0, 0. And then now this column over here, so 0, 0, 1, 0. So 0, 0, 1, 0. Next, 0, 1, 1, 0. So 1, 1, 0. Next, 1, 1, 1, 0. So 1, 1, 1, 0. Then I have 1, 1, 1, 0. Oh, I already did that. Sorry. 1, 0, 1, 0. Okay, so that's 1, 0, 1, 0. Great. And so then the trick is to look at those columns that have not changed. So, we went from zeros to ones, so we don't include this A term. We went from zeros to ones, so we don't include this B term. We went from zeros to ones, so we don't include this C term. Look at this, all zeros for this D term, and since they're all zeros, it's just simply D naught. So if this KMap, if I did this correctly, what this is suggesting is that this whole thing reduces to just simply D naught, and that's as a result of looking at this analysis over here. The only column that hasn't changed is the D column. It's 0, so we put the naught up. If these were all ones, then we would just simply put D by itself. Okay, well, let's see. That's the KMap solution. Now I'm going to go ahead and use the Boolean algebra solution. All right, so let's see if I can type in as neatly as possible here. So we'll simply say Boolean reduction. Okay, and so let me just, again, write as neatly as I possibly can here this expression, and then we'll just start to reduce it. So it looks like I've got D naught, and that's being ORed with C D naught, which is being ORed with B C D naught, which is being ORed with A B C D naught. Okay, well, the first thing that I notice is that everything has a D naught, so let's factor that out. So I'll just simply take that D naught, factor that out. That means that I'm going to have a 1. Oh boy, there's that 1 right there. That means that everything is going to be 1. So I don't even have to write anything. I already know it's going to be 1, but I'll do it just so that you can see what I'm doing. I factor out the D naught here, so that's C. Then I'm going to get BC because I factor out that D naught. And then finally I factor out that A, B, C. So 1 or anything is 1. In other words, true or anything is true. So this whole thing reduces to just simply D naught, which, as you can see, using the KMap approach, right? Using the KMap or the Carnot map approach, we got D naught. Using the Boolean reduction approach, again, we got D naught. So what electrical engineers sometimes do, computer science, the same thing. You use a Boolean reduction, you verify it with a KMap. You use a KMap, you verify it with Boolean reduction. And so in this case, looks like it's D naught. So what's the last thing I'm supposed to do? I'm supposed to draw a reduced circuit. Okay, so it looks like it's just simply the naught of D. So in other words, A, B, and C, they don't matter. It's D that's going to drive this circuit. So I'm going to go over here, and it looks like I'm going to need an inverter. So I'll just simply get this inverter. Of course, you guys are drawing this with pen and paper, but so as you can see what I'm doing over here, all I'm going to do is just simply put D over here, and then of course that's going to be inverted for D naught, and that's my circuit. Isn't that amazing? That whole thing was reduced. Now, with a little bit of experience, you'll see, well, anytime you see these single characters, and if that happens to be inside of these other expressions, and you could just factor that out right off the bat, I can see that D naught factoring that out, that's going to be 1 ORed with this, ORed with this, ORed with this. The whole thing is going to wipe out, and I just end up with D. So I don't even need a ABC signal. I could put it in there. It's just that the only thing that's going to be going through a circuit is D signal. That's going to be going through an inverter to end up with D naught. And that is it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.